800 million jobs are expected to be automated by artificial intelligence by 2030. But as we all know, the construction industry is slow to change. Billion-dollar contractors still manually scan in all their invoices, use paper-based checklists, and run everything in Microsoft Excel. There's been software out there for literally decades that would make all these tasks 100 times easier. But the reality is, in the minds of these contractors, these systems work, so why change them? ChatGPT and other large language models are amazing technologies. And seeing how easily they can perform writing tasks that used to be reserved for the most educated in society, it's a natural question to ask what's coming next and how's it going to change the construction industry? Well, I want to start with a disappointing disclaimer. I, nor anybody else, can tell you exactly what's going to happen. We are terrible at predicting the future. In the year 2000, everybody thought that by 2025, we'd have personal robots in every home, flying cars in commercial use, and fully autonomous cities. However, we're stuck still trying to connect our printers to the Wi-Fi network. If there's one consensus between all the top AI experts is nobody knows exactly how the future is going to unfold. So yes, take everything I'm going to say with a grain of salt, but I've spent over a decade working in the construction industry and I'm currently working on an AI-powered construction estimating and contract management software. On top of this, I'm being super careful with this analysis not to base it on technological advancements that haven't yet happened. I'm very much basing it on the current capabilities of these large language models and other AI systems. So here's how I believe AI is going to change the construction industry, and just as importantly, what's not going to change. So in this video, we're going to be covering what actually AI is, where the technology is likely moving, some important realities of the construction sector that are going to shape how it's impacted by AI, where I believe the short to medium term impacts are going to be, and the major roadblocks to an AI-run construction industry. But first up, let's get started by setting the scene. Let's give you an overview of what actually is artificial intelligence. Put simply, artificial intelligence is just technology that mimics human intelligence. It's got the ability to acquire and apply knowledge to do valuable work. That could be economically valuable, that could be socially valuable. And in essence, what that means is that AI can learn from data, make decisions, and take action. Okay, so AI is more or less a bundled term. It actually means a lot of different things. And now I want to just break it down a little bit and talk about the different types of artificial intelligence or smart machines. So the first form, which strictly isn't AI, but we can think of it as a part of the AI process, is automations or narrow artificial intelligence. These are simple software tools that follow rules or scripts. The classic example being a calculator, where it doesn't think in the way we think, it just follows a set of instructions, often much faster and much better than we can. If you ask a human what 27 times 83 is, it'll take them a while to work it out. If you ask a calculator, it'll give you a correct answer very quickly. Now, narrow artificial intelligence or automations are simply a deterministic process. It's a software script following a set of processes. If we think of this in the context of the construction industry, it might be something like a site diary that automatically populates data into an Excel spreadsheet. So we have a form, we populate the weather, the work that was done that day, what people worked on what tasks, what quantities were complete, and it populates it into a spreadsheet as a record. Now, generative artificial intelligence is the technology that has thrust AI into the limelight recently. It's ChatGPT, large language models, and other tools like that that can generate new content like text, images, or code. These are technologies that, based on what the patterns they've seen in their training data, given a prompt and context, they can format a response to it. So this technology is referred to as a large language model. A large language model is a tool that's been trained on huge amounts of text from books, websites, technical documents, basically all the data in human existence. It learns the pattern, the grammar structures, and the meaning in that data. And when you give it a prompt, it'll predict the next word or image or line of code one step at a time based on what it's learned. Think of it like this. If you type a scope of works includes, the model will then fill in the next blank. So what would normally come after the scope of works includes, it'll then fill in the blank after that. Importantly, large language models, while they seem like they do, they don't actually understand what they're writing. They're mathematical models that predict the next word or token in a change. But this technology is incredibly powerful. So if I use an example from Claude and I've prompted it, can you write an example scope of works for a concrete construction project? It's generated this response from it. It's generated a full scope of work. So Claude is one of these large language models, and based on this prompt I've given it, it's given me the most likely response. So unlike an automation, large language models are probabilistic. That means if I type the same prompt into that same model again, I'll get a different answer. When automations are deterministic, regardless of what you do, they follow a set series of steps. Large language models like ChatGPT or Claude, as you've seen, are always limited to this text interface where we type in a prompt and we receive an answer, which obviously has some massive limitations. The next form of intelligence we're going to talk about are AI agents, which are systems that go beyond just responding to prompts. They can plan a task, use tools, make decisions, and take step-by-step actions towards a goal without being told explicitly what to do. So unlike chatbots, agents act proactively and can handle multi-step workflows. ChatGPT, Claude, if we're using the web browser, we type in a prompt, we get a text-based response or an image if we ask it to generate an image. An agent is a technology that's built on top of a large language models, but with added capabilities such as goal setting, where you can tell it what to do, not explicitly how to do it. Memory, it can remember tasks across time. Tool access, it gets access to external tools like your email, your calendar, Excel, Google Sheets. So it can fill out information, can send emails, can book appointments. And reasoning loops, where across multi-steps, they can break down a task, decide what to do step by step, and then they can determine if things go wrong and check the output of their work. It's basically like, rather than having an AI which is just generating text, you have an AI that has a to-do list and figures out the steps and finds a way to get it done. So let's say your goal is make sure we send out subcontractor RFIs 4 weeks before we need them on site. The AI agent would break this task down and determine it needs to check the schedule, so it would connect to your project schedule, determine when the different subcontractors are starting on site, identify the upcoming work packages, check if RFIs have been sent, if not, draft and send them, track the responses, and notify the project manager if anything's overdue. All we're doing is setting the outcome and the agent handles the process. Again, this technology is built on top of large language models. Now, an important distinction and where people often confuse the two, and I definitely confuse the two for ages, is you can have an AI workflow, which is an automation, so a set series of steps with a call to a large language model in it, like a prompt, or you can have an AI agent. The difference is a workflow is simply a set of steps that refers to a large language model. It's got fixed logic. So for example, when an RFI is submitted, send it to ChatGPT to summarize and email the project manager the result. That's an AI workflow. An agent is where the large language model, the AI tool, is deciding the steps it goes through, and it can adapt based on what's happened. So for example, you'd set an agent a goal like keep the RFIs under control, checks the RFI logs, sees what's late, sends follows up, updates the dashboard, and flags issues. Agents are where we really get into the realms of using these AI tools as autonomous workers as opposed to just tools to generate content. Okay, so far we've spoken about intelligence behind the computer screen. The really exciting thing for the construction industry will be when this intelligence interacts with the real world through intelligent machines and robotics. These are machines where AI is integrated into the hardware, allowing machines to perceive the real world, make decisions, and perform physical tasks. For example, a self-driving car that's able to navigate through the city on its own, a robot dog that can walk through a construction site, avoid obstacles, and scan progress and update a progress tracker, or a warehouse robot that picks items off shelves and loads them onto pallets. These systems combine sensors, AI models, and robotics hardware. We're already starting to see a little bit of this on construction sites where they're using drones for site inspections and mapping, robotic survey equipment, autonomous earth moving equipment, and, well, we're not really seeing this yet, but concrete printing robots. So this is where we're taking the AI out of the computer and it's interacting with the real world. So to briefly summarize, artificial intelligence isn't just one thing. It ranges from basic automations, which we've had for years, generative tools like ChatGPT and Claude, to agents where these tools start to perform tasks autonomously, and then eventually to robotics, where this intelligence is used to complete work in the real world. So now we understand what AI is, let's now talk about where the technology is moving. Are we about to see artificial superintelligence and all be out of work in 18 months, or are chatbots and large language models as far as it's going to go? One of the tough things about AI is there's so much fear and hype. There are tech CEOs that are desperately trying to raise money from investors, so they're pumping up the technology as much as possible. And then there's a whole group of people who prompted ChatGPT once, it didn't give them the answer they wanted to, so they've written it off as a complete waste of time. Well, the truth probably lies somewhere in the middle. So now let's explore some of the near-term advancements we're likely to see in AI. These aren't my opinions, these are what the experts in the field are saying. AI is currently like having access to Albert Einstein, but he's locked in your basement and you can only pass him notes and information to get requests. You can ask him, how does an electrical transformer work? And you'll probably get a very good answer. But if you ask him a question like, which electrical transformer is best for my project, he won't be very helpful because he doesn't have the background context, he doesn't know your specific situation. The next evolution of AI isn't necessarily going to be about making Albert Einstein smarter, it's going to be integrating these tools into our work every day. It's about connecting these models with real-world data, tools, and giving them decision-making authority. Here's where the technology is going and what the top researchers and labs are saying. So the first and most obvious trend is simply moving from the text in, text out, chatbot style interactions we're having to integrating these tools into the real world. We're going to see AI integrated into your calendar, your email, your Excel spreadsheets, all the different tools you work. So rather than just simply getting text back from a text input, going to start to see these AI doing real work through automations, integrating them into automations as we discussed about, but also giving them agentic control. And Microsoft's Kevin Scott says the exact same thing. And it's more or less an obvious conclusion to draw that AI is going to get exponentially more useful as it's plugged into more systems, our calendars, our emails, our logs, our sensors, so it can do real work. It's going to get given more context, more decision-making authority, and access to more tools. The big one I see as being incredibly important in the shift forward is as AI gets access to more information, it's got more context and it will make better decisions. It doesn't actually need to get more intelligent, it simply needs more information. So if I ask ChatGPT, what transformer should I use for my project, but I don't give it any information, I'll get a generic answer. If I ask ChatGPT what transformer should I use for my project, but it's got access to the design drawings, it's got access to the project schedule, it's got access to all our past supplier performance, the vendor quotes, the project location, it's able to analyze this, take this all as context, and give us a very specific and likely useful answer. Okay, so the next trend that's worth discussing is that current advancements in large language models may slow, but labs are exploring new methods to reach artificial general intelligence. Now, I've already said, I don't actually think in terms of how useful AI is going to become, that this is an incredibly important tool. I think when you use tools like Claude and ChatGPT, it's already incredibly intelligent. Sure, sometimes it hallucinates, sometimes it gets things wrong, but it generally gives you very good answers given enough context. So if it's got access to tools, access to enough information, then this generally won't make a massive impact. But everyone's saying that scaling the models, the current large language models we have, with more and more data, more and more computational effort going into training the models, isn't necessarily going to get us to artificial general intelligence. So GPT-4 was powerful, but its improvements over GPT 3.5 were incremental, not exponential. The top people in the field are saying the same thing. Sam Altman, the CEO of OpenAI, has said, we're not just going to get there by making the models bigger, they're going to need new ways, new methods of generating intelligence. Jan LeCun, Meta's chief AI scientist, says the current large language models are not capable of reasoning, they're trained to fill in the blanks, not to plan. So what's next? We're going to see different tools being used to solve problems, increases in memory and context, plan of thought modules such as chain of thought prompting and tree of thoughts, and also multimodal integration such as text, video, audio, and sensor data. The next advancement that we're certain to see, and everyone's been saying it for the last 15 years, is that driverless vehicles and robotics are going to continue to gradually expand. So fully autonomous systems in chaotic environments like construction sites remain extremely challenging, but controlled repetitive environments like mining, warehouses, and precast factories are already starting to use more and more robotics. I think everyone thought driverless cars were going to happen much faster, but as Elon Musk has recently said, when you're interacting these robotics with chaotic real-world environments, there's a huge long tail of edge cases that are harder and harder to train the models to adapt for, which has slowed down the overall adoption. If you look, the CEO of Built Robotics has said a very similar thing where they're focused on easy, repeatable, high-risk tasks, not building general-purpose complex robots. They're very focused on trenching and grading repeatable tasks. So what are we likely to see? In construction, we'll probably see robotics first scale as a service through labor hire companies with things like drone scans, rebar tying bots, layout automation, and sites with repeatable processes like solar farms, wind farms, mining projects, without a lot of interactions with the public. You're going to be the first to adopt these. So to summarize, there's really the three trends we're seeing. We're seeing AI is going to start moving from chatbots to interacting with real world tools and templates and being able to do economically valuable work. The linear progression through the large language models is unlikely to continue. It relies on not so much scaling up the current models, but more about speculative technology to get us closer to both artificial general intelligence and superintelligence. But without further huge advancements in these models or these technologies, AI is already capable of doing incredibly useful work. It just needs to get plugged into more technologies, and the path to intelligent machines interacting with the real world is likely to be much slower. Without huge advancements, artificial intelligence can already do some amazing things. But the construction industry has some important realities that are going to shape how AI is adopted. For us to make any sort of meaningful and specific prediction about how AI is going to shape the construction industry, these are the factors we need to consider. The next factor I want to talk about, which is very important in how we allow AI to make decisions and actually give it authority to do things, is that construction is high consequence. Mistakes can cost lives, millions of dollars, or huge amounts of disruption. So unlike software where you can just ship updates, and if there's some issue, maybe your software goes down for a couple of hours while you fix it, construction just isn't like that. You can't do a concrete pour, then decide to change it later without spending tens of thousands of dollars. The risk profile means that new technologies are always treated cautiously, especially when it touches safety, contract critical processes, or spending money. Why does this matter? Again, it's hard to see humans purely relying on AI generated decisions and content without some form of checking or verification for a very long time. The next reality of the construction industry is that tools and processes can never replace execution on the ground. What do I mean by this? Well, say you're preparing a software program and you write a perfect bit of code generated by an AI. You run the code, it does exactly what you want. Construction just isn't like that. There's such a human element to it. So for example, you ask AI to generate the perfect schedule, the perfect estimate, the perfect project management plan. You don't have people who can interpret, adapt it, and lead it and implement it. It's completely worthless. Technology, as it stands now, can't replace judgment, leadership, and experience. You need people to implement the plans. And it's always AI, I believe in the construction industry, until you've got intelligent machines and robotics that are doing all the work and there's no human element, it's always going to come up against this limit of how useful perfect documentation and plans are. Perfect implementation is fundamentally what matters, and it's hard to see in the short term or medium term how AI can support this when there's such a human element to construction sites. So to summarize, the realities of the construction industry is that construction is complex, high risk, and people driven. AI prefers clean, predictable environments. But with this important point I made at the start, that overhead and indirect costs are a huge portion of a construction project's budget. So there's a huge amount of money to be made for contractors who can reduce this portion of their project costs. So let's combine our understanding of what AI is, where the technology is likely going, and the realities of the construction industry to make some predictions in the short and medium term how AI is going to change construction. Here are 9 trends I believe we're going to start seeing in the short to medium term. The next important trend we're going to see, or I think we're going to see, is that the typical historic general contractor is going to lose ground. AI is going to put a lot of pressure on general contractors, which are basically project management organizations. As tools and software and systems get better at actually doing a lot of these tasks for us, the ability of a general contractor to put a 15%, 10% margin for managing trades, project managing a project is going to be crushed. We're already starting to see this a little bit on major projects where owners are shifting to this model called EPCM, where the owner takes on the engineering, procurement, construction management using tools to manage the design, the procurement, the construction. They're managing their own trades. And it's going to cut the management layer the general contractors put on and their profit margin. Basically, it's going to be cheaper to build stuff if you manage it yourselves using these AI tools and software rather than paying a general contractor to do it for you. The general contractors that manage these projects and rely on employing project engineers, project managers, contractor administrators, cost controllers, these sorts of employees, and they don't self-perform the work themselves, I think you're going to feel a real squeeze, and it's going to be increasingly difficult for them to justify their margins. This is going to benefit owners. They're going to get more control of the project. They're going to be able to save money, and we're already seeing it in mining and energy mega projects where they already run lean with an EPCM model, and major building projects like data centers are already moving in this direction. I think you're going to see it more and more with smaller projects as you get better software that effectively allows you to manage the project yourself. Again, in line with this trend is I think you're going to see more and more labor hire and self-perform contractors. Again, till robotics gets a lot better, skilled trades are going to stay irreplaceable, but AI is going to be getting better at the coordination and driving of how they're performed. Again, in the near future, AI isn't going to be able to tie steel or pour a slab, but it'll be able to decide who should be doing it, when and where, which I think is going to lead to more of a rise in self-performed subcontractors completing small packages of works getting managed by a project owner directly, not via a general contractor. And same with labor hire companies where AI matches the crews, the scopes based on the weather, sequencing, the project updates, productivity data. Again, tools like Assigner are already being used to optimize subcontractor scheduling, and future platforms are only going to get better at doing this. The next trend, which I've already spoken about a little bit, where I thought the role of the contractor administrator would diminish, and I haven't really seen this playing out yet, but I think you're going to see smart contracts. You think effectively what a contract is. A contract is a massive rule book, and this role of reviewing the contract, interpreting what people have to do, it's going to get much more smarter and much more efficient, where contract automations are going to help reduce disputes. People are going to get paid based on objective measures from objective measurements. There's going to be set tasks that people have to perform. It's all going to get much more automated and much more simple and faster. Again, tying back into this where general contractors are going to struggle to justify their margins, it's going to get easier and easier to both manage subcontractors and subcontractors to directly work for owners. And we already are seeing some pilot projects using this. For example, in the UK, there's a pilot project which uses AI verification for milestone payments, and they think it's going to help reduce contractor cash flow delays by up to 30%. Anyone in the construction industry knows how important cash is in getting paid on time. So I think this is going to be a very positive trend. The next trend I believe we're going to see is more and more modular and off-site construction. Again, we've already spoken about how AI thrives in easy, repeatable processes like manufacturing. If we extrapolate this out, I think there's going to be much more prefabrication and off-site work where it gets easier and easier to manufacture stuff. And then our on-site work is going to be much more assembly, putting things together by designing, sequencing, and optimizing the builds. Factories thrive on repetition. AI is going to make real advancements in making it cheaper to manufacture things, which means more stuff on construction sites is going to get pre-manufactured. Site work is going to become much more about site assembly than construction. And if you look at the picture, that's actually a building being built in modular components. So all these separate apartments have been fabricated off-site, delivered to site, and they're simply craned into position. And again, as an extension of this, construction is going to move more from looking like a whole lot of skilled trades working in different areas to much more like manufacturing, putting stuff together. I've worked on a project where recently it was a major oil and gas project in Australia. Everything actually got built in Thailand. Then they shipped these huge modules to site. All we did is connect them up and hook them up together. Everything was done off site. And again, I think as AI gets better at these repeatable, easy to manage tasks, you're going to see more and more stuff built off site, less and less stuff built on site, and construction just going to look like doing the final touches and bolting things together. The next trend I think we're going to see in the near term is we're going to start to see the use of robotics on construction sites, but not by contractors buying their own plant. It'll be by specialist planners. I think robotics is going to come out, but there's going to be all these painful rules and regulations. It's going to be hard to set up, hard to optimize. You're going to start to see these specialist plant hire firms that specialize in construction robotics. So robots will hit the site like we would a crane hire, not like a co-worker for a contractor. You won't necessarily own your robot dog for site inspections, but you'll hire it from a specialist firm who combines both the upfront investment in the technology, but they're experts in setting them up, optimizing them, and using them. And also they organize all the maintenance and inspections. And it'll come into the construction industry in the shorter term as a service. To summarize, here's how I think in the near term, we're going to see artificial intelligence play out in construction. We're going to see changing project teams and job roles, less and less boring, repetitive administration work, and how jobs are just going to get much more harder and challenging. They're going to be much more about the human side, the chaos side of construction. I think general contractors, probably more over the medium to long term, are really going to struggle to justify their margins as software and tools gets better at replicating their jobs. I think smarter contracts is going to be a much better thing for the construction industry, much less disputes, much less late payments. Construction is going to move much more to modular offsite construction and more of assembly, and that we're going to see specialist robotic plant hire companies. So let's not get too carried away. We all know that the construction industry has a reputation of being very resistant to change. I want to finish off with some reasons why the AI adoption in construction may end up being much slower than we think. So I've already alluded to some of these major roadblocks, but I thought it's just worth recapping them because at the end of the day, AI thrives on structure and data, but construction offers chaos and context. So these are some of the reasons why I think the shift to AI and robotics might actually take much longer than we think. First one is messy and unstructured data. Yes, construction generates a lot of different documentation, but it's often scattered across calls, chats, spreadsheets, emails, and paper, and there's often no single source of truth. AI can't make good decisions if it doesn't have access to complete or clean inputs. Say for example, there was a verbal agreement between a contractor and a subcontractor to work on the weekend, but the AI only sees the original program that was never updated. So when a subby invoices for the extra weekend work, the system automatically disputes it. The next challenge I see is that a lot of the learnings from a construction project, referred to as tacit knowledge, stay trapped in people's heads, embedded in their experience. So construction relies heavily on informal experience and judgment. That's what we referred to as good construction managers having a good gut feel or good experience, because they've dealt with these specific situations, although it may never be recorded anywhere. If it's never recorded anywhere and AI doesn't get access to it, it won't see it, it won't be able to use the information, which is so much of the experience and learnings from construction companies. Project manager might choose to avoid a certain supplier in tropical zones due to repeated failures they've had on past experiences, but without the pattern documenting it, AI is going to continue recommending the same product. The next challenge I see is that ultimately liability and responsibility for AI generated output is always going to still rest with humans. If AI makes a critical error, contractors are still legally and financially on the hook, and AI does hallucinate and makes mistakes. Insurers, regulators, your company's management aren't going to accept the AI did it excuse. For example, if you get an AI generated safe work method statement and it misses a critical step and somebody gets hurt, that's not going to be excusable. Someone is still going to have to review the output. Even if it's correct 99.9% of the time, it's still not going to be checked because it's such a high risk industry. At the end of the day, someone is still going to be liable and responsible for it, so someone will need to check it, which again, at the end of the day, is just going to slow everything down a lot. Related to this point is the unfortunate reality that AI can't be trusted blindly. AI tools can hallucinate, generating outputs that sound plausible but are factually wrong. In many cases, verifying the AI output can take longer than doing the work manually. So if you have an AI system that is, because they're probabilistic, if you have a system that is 99% accurate, to actually get it to 99.9% accurate is a 10 times improvement in the system. So actually getting these almost certainly correct AI systems is incredibly difficult and challenging. Why is it a 10 times increase? Because in the 99% accurate system, you have a 1% failure rate. The 99.9% system, you have a 1 in 100 failure rate. So you're actually reducing the failure rate by 10 times, which requires significant improvements in the models. Again, people are just going to have to check the work, and in a lot of instances, if you're going to have to check it anyway, you might as well just do it yourself in the first place because it'll be quicker and easier. For example, if an AI produces an estimate, but the project manager must cross-check it against site conditions, contract terms, and legal clauses, might just be quicker for them to do it themselves. The next problem with AI, and where I see it being such a big issue in construction, but the same issue that you can't trust it blindly, is when people start to get complacent and over-reliant on it, and you start to see big problems crop up, which is going to cause companies to push back against people using it. Once these AI systems are in place, teams may stop questioning and checking it properly, and in high-risk industries like construction, these blind trusts can lead to unsafe decisions, scope gaps, and major delays. For example, if a planner accepts an AI resequence program to save time, but fails to consider site constraints, leading to a subcontractor mobilizing on the wrong day and paying a delay, maybe the contractor gets charged with a huge delay, and then they stop using the AI tool because the 2 hours it saved the planner weren't worth the $25,000 delay claim. Okay, the next challenge I see is that currently the way construction projects are run is that there's a lot of different tools that don't natively talk to each other. So construction teams might have to juggle lots of disconnected tools like Procore, Aconex, Excel, WhatsApp, and Dropbox. And that is just a function of that every construction project is different. Maybe on one project, your client is using Aconex, and that's how they're transmitting you documents, but your document management system is TeamMiner. So for this project, you have to use Aconex, which doesn't work with the existing tools you've already got. So you have to set things all up from the beginning. Again, this is why I think this job role of the AI workflow engineer or the construction workflow engineer, whose job it is on each project to set up the unique specific tools and processes that are going to be used, is incredibly important. And the final reason is just because of the high risk nature of construction, I think there's a very strong natural resistance to change. Construction teams often resist new systems because the cost of failure is so high and the old methods still work. Every change you introduce causes disruption, causes a loss in performance. Maybe it's worth doing it because the tool's so much better, but maybe it's not. Even if AI did offer big gains, it'll still fail when teams don't trust the output, don't feed it clean data, and keep fallback processes just in case. For example, a contractor deploys an AI-based reporting tool, but supervisors keep entering all their stuff, all their information into their paper diaries. The AI is never going to be that useful. So you need a broad adoption of the tools. And in the construction industry, there is this huge resistance to change. AI in construction won't fail because it's not smart enough. It'll fail because the data is too messy, the tools don't integrate, and people don't trust it. So there you go. There's my 2 cents on how I think AI is going to change the construction industry. I think it's going to make a massive difference. That's why I'm making a big bet on it, and I'm investing my time in building an AI-powered construction estimating and contract management tool. I want to use it to make our lives easier and solve some of the real problems our industry faces. If you're keen to check it out, I'll put a link to it in the description of the video.